There's a place in the night sky, close enough to feel familiar, and yet far enough to gently pull your thoughts outward. Not far beyond your own horizon, beyond what most people ever stop to notice. There exists a star system that has watched Earth from the beginning of time. And tonight, we'll move there slowly, like drifting in calm water, without urgency, without pressure, without needing to understand everything all at once. This is Midnight Lab, and this is your journey to Alpha Centauri, a place that sits at the edge of the familiar, yet it's truly the closest star neighborhood to us. Alpha Centauri is not just a name, it's a doorway, a quiet reminder that the universe is vast and still somehow gentle, even when it's unimaginably far. Before we begin, just take one comfortable breath and let your shoulders soften, let your jaw relax, let your eyes feel heavy if they want to. And as you listen, you can let the story carry you, the way waves carry sand little by little, until you're not holding onto anything at all except the comfort of the sound of your own breathing and the gentle cadence of these words. So now, imagine the night sky from far away. Imagine you're in a calm, dark place. No city lights, no sudden noises, just the steady velvet of space. Somewhere in that darkness, a small cluster of stars waits. Alpha Centauri appears to the naked eye as a subtle point, most easily seen from the southern hemisphere, a quiet companion of the sky. And yes, your mind might wonder, how far is it? It's close in cosmic terms, but still enormous in distance. Because even the fastest spacecraft would take longer than a human lifetime, longer than most stories, longer than you can measure with normal time. It's about 4.37 light years away. That means the light you see from Alpha Centauri has been traveling patiently across the void for 0.37 years for each photon of light that reaches you. And that gentle delay is part of the feeling tonight, because you're not just looking at stars, you're looking back in time, just slightly, into the steady light of a neighbor system. And now, as your mind settles, we'll let the story unfold slowly, because Alpha Centauri isn't one star. It's a small family, a small and balanced arrangement of three main members orbiting in a way that feels almost like choreography. Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. 3 stars, 1 system. And they move in their own rhythms, long rhythms, rhythms that are more like seasons than moments. So let's begin with the first, Alpha Centauri A. Alpha Centauri A is a main sequence star. In simple words, it's the kind of star that behaves like a stable sun, burning hydrogen in its core. And even though it's not your sun, it has a familiar resemblance. Its mass is about 10% greater than our sun's. Its radius is about 22% larger. Not enormous differences, more like a slightly bigger version of something you already know. And when you hear that, you can let your mind rest. Because tonight, you don't have to picture something terrifying. You can picture something calm, something steady, something that has been shining for a long time. Stars like Alpha Centauri, they don't change quickly. They don't flicker like distant candles in wind. They shine with a consistent, patient light, light that has its own tempo. Alpha Centauri is like the steady anchor, the first member of a quiet neighborhood. And if our sun is a warm voice in your sky, then Alpha Centauri A is a similar voice, just slightly deeper, slightly warmer in presence, and still fundamentally understandable. Now, as the story continues, we approach the second star, Alpha Centauri B. Alpha Centauri B is also a main sequence star. It is smaller and cooler than Alpha Centauri A. Its mass is about 90% of the Sun's mass. Its diameter is about 14% smaller than its companion. And in many ways, it feels like a contrast. Not a dramatic difference, but enough to create a unique personality within the system. A smaller star, a slightly cooler glow. Yet, here's an interesting detail. Despite being smaller, Alpha Centauri B emits more X-ray radiation than Alpha Centauri A. And that might sound like something intense, but in the calm context of tonight, we can frame it gently. It means that Alpha Centauri B is more magnetically active. more energetic in certain wavelengths, more alive in the invisible language of radiation. And while you might not see these X-rays with your naked eyes, the existence of this activity is part of what makes the system dynamic. Not unstable, just active. Imagine a quiet room with a warm lamp and another lamp that gives off more heat, more subtle energy. Both are steady, but one has more motion beneath the surface, and that is Alpha Centauri B. Now, the two stars, A and B, do not simply sit like separate points in space. They orbit each other. They move around a common center of mass, locked into elongated paths, looping around in a rhythm that takes about 80 years. 80 years in their orbital cycle. 80 years is slow enough that life on Earth would experience the story as something that changes gradually, as something that feels like weather, not like sudden fate. And the fact that they orbit together means their gravitational relationship shapes the system's atmosphere, environments, and eventually the kind of planets that might exist within it. So now we step farther out, because beyond A and B, there's a third companion, Proxima Centauri. Proxima Centauri is a red dwarf, and that description alone invites a calm mental image. Red dwarfs are smaller stars, long-lived stars, stars that burn with less intensity, but with patience that can last far beyond what most people realize. Proxima Centauri is the smallest of the trio, yet it is the one that matters most for proximity, because Proxima Centauri is the closest star we have, aside from our own sun. Its orbital path is so vast that it takes more than 500,000 years to complete a single revolution. 500,000 years is so long that it's almost not meaningful in human terms. It means that from Earth's perspective, Proxima has been near enough for so long that our curiosity feels timeless. Proxima Centauri shines much more faintly than our sun. It is more than 20,000 times fainter, so faint that it is invisible to the naked eye. You need instruments to catch it. You need a certain kind of attention. And the beauty of that is, the most meaningful things aren't always the ones easiest to notice. Proxima is there, quietly, waiting in the shadows of the system. And around Proxima, there may be dust. There are two vast dust cloud rings. Dust rings can be like leftover material, like the footprints of earlier times. Material shaped by gravity, slow and persistent. And then, in 2016, hidden beyond those clouds, something extraordinary was discovered. Something that changed the feeling of this story. A planet close to Proxima, and it is called Proxima B. Proxima B is one of the closest exoplanets ever found. It represents the closest known planet outside our solar system. And that alone can be enough to send wonder into the quiet corners of your mind. A rocky world in a neighborhood, not at the edge of the galaxy, but right next door in astronomical terms. Its density suggests a rocky composition, so it's not a giant gas balloon drifting through space. It's more like Earth in its potential character, solid, grounded. Its size is estimated to be slightly larger than our home, and its mass is around 6% greater than Earth's. That means its surface gravity could feel remarkably familiar. Not identical, but close enough that if conditions allowed, your body might recognize the feeling of a world like that. But the distance from its star is the part that turns the story into something extreme. Proxima B orbits incredibly close to Proxima Centauri, 7.5 million kilometers away, 8 times closer than Mercury orbits our sun. And in that closeness, the planet's year is not long. A single year on Proxima B lasts just about 11 days. 11 days. Imagine the pace of seasons, if there are seasons. Imagine how quickly the system's day-to-day rhythms repeat. But we also have an important concept to breathe into gently. The habitable zone. The habitable zone is the region around a star where temperatures could allow liquid water. It's not a guarantee of life. It's not a promise of comfort. It's just a possibility based on energy balance. And Proxima B sits within that zone. So it has a kind of maybe to it, a maybe that is both hopeful and challenging. Now let's slow down and describe the challenge. Because when a planet orbits that close, the likelihood of it being tidally locked is strong. Tidally locked means the same side of the planet always faces the star. So one side is always in daylight, and the other side is always in darkness. One hemisphere, baking, the other hemisphere, frozen. And this is where the story can become intense if we speak it like a threat. But tonight, we speak it like a study, like a calm observation of physics. Dayside temperatures could reach around 100 degrees Celsius. That is extremely hot. Radiation could be harsh, a desert-like terrain. And in the far darkness, on the night side, temperatures could drop below minus 150 degrees Celsius. Freezing, ice. And if there were an atmosphere, it might collapse as frost onto the surface, leaving a world with barren regions on both extremes. Yet, here's where the story becomes soft again, because there could be a narrow twilight strip, a corridor between endless heat and endless cold, a region where conditions may stabilize. And that region has a name you can hold gently in your mind. The Terminator line, the line between day and night, the boundary between fire and ice. And in many ways, it's a metaphor for this entire journey, because it's exactly in the boundary, in the transition, where something lifelike could potentially survive. Not in extremes, but between them, between the harsh and the gentle, between the bright and the dark. So let your mind picture a quiet world where the edge between light and shadow acts like a soothing climate. A place where ocean, mist, and warmth might exist. A narrow belt of possibility. Liquid water could flow there, if the planet's atmosphere and magnetic environment allow it. And if life ever took hold there, life might not resemble anything you already know, because life shapes itself to its environment. Life is adaptive. Life learns. Plants might need to harvest every photon, every little bit of light, because sunlight there is weaker than on Earth. Vegetation might grow deep green, or perhaps even black. Yes, black, because black pigments could be efficient at capturing whatever light exists. Leaves might be broad and waxy, more armored against stellar flares and bursts of radiation. Life shaped by shadows. Life shaped not by seasons of the year, but by the shifting geometry of day and night. Now, of course, there are still challenges, because Proxima Centauri is prone to massive stellar flares. Flares can strip an atmosphere over time. They can bombard the surface with energetic particles. And that's where the hopeful detail appears. If Proxima B has a strong enough magnetic field, life might survive despite the storms. So the world isn't simply one thing. It's a balance of threat and protection, a balance that physics alone can suggest. And then we learn something else. Proxima B is not alone. Astronomers have detected 2 additional planets orbiting Proxima Centauri. The first is Proxima C, a so-called mini-Neptune. It orbits much farther out, around 200 million kilometers away, far beyond the habitable zone, so its surface would likely be frozen. Average temperatures could be far below minus 200 degrees Celsius. In other words, it's a distant, cold companion. And the second is Proxima D, a tiny rocky world. At only about 25% the mass of Earth, it is among the lightest exoplanets detected. But it lies extremely close to its star, around 4 million kilometers away. At such an extreme distance, its year could last just 5 days. A very fast orbit, and its surface would likely be scorched and lifeless. Together, these worlds form a system of extremes, a mixture of nearby harshness and distant cold. And within Alpha Centauri, we can imagine the possibility that planets follow different destinies based on their orbital distance and the behavior of their star. This is the scientific truth. But tonight, we're not here to scare you. We're here to guide your mind into calm curiosity. Because even though these planets sound intense, daylight that never ends, night that never ends, flares that rage, there's still something deeply soothing about the fact that the universe is understandable. It follows rules. It follows patterns. And if you follow those patterns quietly, you can find comfort in the idea that everything has a reason. And now, after we've traveled the system's members, we reach the part that stretches the human heart. Because even if we don't go there tonight, Even if we don't touch those worlds, we can dream of reaching them. And a bold idea is taking shape. Breakthrough Starshot. Breakthrough Starshot imagines sending extremely small spacecraft toward nearby stars. Not big ships, not massive rockets. Instead, tiny probes only centimeters wide. They would be powered by solar sails, and they would be propelled by a ground-based laser array. A laser pushes light pressure, and that light pressure can accelerate a spacecraft across immense distances. The goal is ambitious. Accelerate the probes to about 20% the speed of light. Not full speed of light, but still a staggering fraction. At those speeds, a probe could reach Alpha Centauri in just over 20 years. 20 years. That's still not instant, but it's fast enough for a generation to witness the result. It's the difference between a cosmic dream and a cosmic mission you could actually imagine in your lifetime, or at least in your lifetime of memories. This would be the first interstellar mission, not carrying people, no human bodies, no cities. Instead, instruments, cameras, sensors, evidence. Proof that we can extend our curiosity beyond the solar system. Proof that we can send our attention to another neighborhood and receive something back. A message in photons. A return of information. And if we imagine that happening, imagine a probe arriving at Alpha Centauri. Imagine it sending back data. Imagine it capturing images from another sun. The moment humanity sees that world, the moment we receive confirmation of what's there, it would mark a turning point unlike anything else in history. Because it would mean we're no longer confined. We're not just residents. We become travelers, interstellar travelers. But tonight, we don't need to sprint into the future. We can simply let this idea float. Let it be a soft thought, a gentle dream. Now, as your breathing slows, we can revisit the feeling of the system from another angle. Because even though Alpha Centauri is far away, it is still close in meaning. It stands as the nearest star system beyond our own, a neighbor we can observe, a place we can study, a place that invites patience. And patience is a form of calm. So perhaps tonight, you can practice patience. Like waiting for light to arrive. Like waiting for a story to unfold. Like letting your mind settle in its own time. And as you drift, we can return to the simplest truth of all. Alpha Centauri is 3 stars. A and be locked in an 80-year dance. Proxima moving slowly in the background, and at least one planet. Proxima B, living within a habitable zone, but wrapped in extreme day and extreme night. That tension creates a specific kind of possibility. A possibility that life, if it ever happened, would learn to survive at the edge between fire and ice. A world where shadow becomes climate. A world where the boundary itself matters. So maybe that's what you take with you. Not anxiety, not fear, but the idea that in every difficult environment, there can be a place where conditions stabilize. A place where transition creates life. And now, we can slow down further and give our mind a chance to fall asleep with a gentle closure. Before we end, I want you to remember this. You don't have to go anywhere. You already traveled just by listening. Your imagination moved across light years. Your attention stretched and softened. And now, your body can return to stillness. Your mind can return to quiet. And the universe can remain big without feeling overwhelming. Because tonight is for rest. So as this story reaches its final breaths, let's send the last thoughts gently into the night sky. Alpha Centauri, the stars next door. A reminder that beyond the familiar, there is wonder. And beyond wonder, there is calm. There is always a next breath. There is always a quiet landing. There is always time. Soft OUTRO, sleep safe landing. As your eyes grow heavy, as your body settles, let the sound of my voice become something you no longer need to follow. Let the words fade into a background hum. Let the science dissolve into atmosphere. Let the images behind your eyes become slow and dim and comfortable. And if thoughts come, let them pass like distant planets. You don't need to hold on to them. You don't need to answer them. You can simply rest from one star system to another in your mind. And now, in your body, in this room, you can let sleep arrive. Good night.